Hey, what's going on, guys? My name is Zero Davila. Welcome back to Save Our System IT. Today we will implement in Java an incarnation of the divide and conquer search algorithm, and more precisely the binary search using a binary tree. A binary tree is made up of a multitude of nodes that contain a value and 0, 1 or 2 successors. The node on the left will always have a smaller value than the root, and the node on the right will always have a bigger value. Each node has a single predecessor, with the exception of the root, which has none. So if we have an array of 9 elements and we want to search the position of key 4, first we must fragment the array in half. The root is the center of the array, so it's 5. Because 4 is less than 5, we will only search on the left side of the tree. And by doing so, we just cut in half the number of possible options and the search time. To the left, we only have the value of 2. Because 4 is greater than 2, we will continue to search only on the right side of 2 in the binary tree. And we just cut the number of possible options in half again. We reach the node that has the value of 3, 4 is greater than 3, and we will find it at the next successor node to the right. Now let's implement this in Java. So vi BinarySearch. First we must write the class, public class BinarySearch. And our first method called BinarySearch will contain the logic for our algorithm, and it will receive two parameters, an integer array to search through, and the integer that will be the key we must search for. So an int array, input array, and an int called key. Before all else, we must index the start and end of the array to be able to find the middle, because the root of our binary tree will be the middle of the array. So the start variable will be for the moment contain the value of 0, and the end variable will contain the length of the array minus 1. What forms the data structure known as a binary tree exactly is the fact that the variable containing the middle of the array is inside the loop. So the array will be fragmented over and over, forming the nodes. As long as start will be less than or equal to end, we will index the middle of the array inside the variable mid. And we will do this by adding up start and end and then divide it by 2. If the element we're looking for is already at the middle of the array, that means we found what we were looking for, and we will return it. So if key equals input array mid, we will return mid. If key is less than the middle of the array, then we will keep searching for it on the left side of the tree. So the loop will index the middle of the left segment. And if the key we're searching for is greater than the mid, we will keep searching for it to the right. Now end equals mid minus 1, and searching it for the right, start equals mid plus 1. Now let's close the if statement, close the loop and return minus 1. It's time for the main method, where we will first of all create a new instance of the class BinarySearch inside the binary variable, and then offer two arrays in which we will search for the position of an element in each by calling the BinarySearch method with the array and the key as arguments. So BinarySearch equals new BinarySearch, integer array r. Let's give it a 2, 4, 6, 8, 10, 12, 14, 16. Now to print it, we have a system out print line, and let's search for element 14. So position of element 14 is, and then add this string up with binary.BinarySearch to call the method, and offer the array and element 14 as arguments. And let's do it again. So an integer array called arr1. This will be 6, 34, 78, 12, 432, 9000. So again, system out print line, position of element. Let's search for 432. and then again we call the method binary.BinarySearch, offer the array and the element. Close everything up, save the file, compile it, and it worked, first try. Now let's execute the script, and as we can see, it worked. And well, that's about it for today. Don't forget to like, share and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sosit.co. Again, that's www.sosit.co. Thanks for watching and have a nice day.